Okay, so the transformations, the parent function looks like this, just 1 over x, simple. Nothing is affecting it. It's just the number 1 being divided by x. Usually parent functions start at the coordinate 0, 0. But are you allowed to divide by 0? So instead of this function starting at 0, 0, its asymptotes are at 0 and at 0. And what does this graph look like? Well, here you go. This is what function 1 over x looks like. You see where the asymptotes are. It's at y equals 0 here, and at x equals 0 here. So transformations are a little bit different. Usually on the notes that we've been doing, we've been dealing with functions that look like this, but this is not in a transformation form. We've been factoring and finding characteristics. If you know your transformations, you guys will actually prefer this format because it tells you your characteristics right away. And I'll show you why. Okay? So let's start with h value. So here's the parent function, 1 over x. What happens if I put an h value, say x plus 2? Do you guys remember? What happens if you have an h value next to the x?
Isn't that when it shifts?
It does shift, but which way?
Oh, yeah. To the right. To the right.
Left or right?
Right.
Okay, well, we'll go through this, but right now, what is it right next to? What letter? So we know it's changing the x value somehow. And it says that it's adding 2, and in our brains, we automatically think, oh, it's going right to then, because we're adding 2. But if you remember a long time ago, I said, well, we can't assume that we're going right to, because x is not by itself. Y is by itself, right? So I told you guys to think of doing the opposite of this. What's doing the opposite to solve for x? The opposite of plus 2 is minus 2. And what's going to happen is it's going to translate left to, the opposite of what we think. So what will that look like? Well, here's the parent function. If I'm taking every single x value on here and I'm moving them left to, what else is going to move? The asymptote will move. This vertical asymptote will have to move as well. So if I pick everything up and I move it left to, the new asymptote would be here, and then the graphs would be here. That's just a sketch. It's not really pretty. But you pick everything up and you slide it to the left too. And I'll prove that in your calculator. Get your calculator out, go to the graphing. Y equals here's the parent function. Whoops, hold on. I had something different in there. There. There's the parent function. Asymptotes are 0, 0, yes? Okay, so now let's change that x value right here. I want to add 2 to it. We assume it's going to go right to, but pretend you're solving for x. You look at the graph, everything got slid to the left 2 units, including that asymptote right here. It is at what? Negative 2. So let's go ahead and fill in part of the h values. If we are adding an h, what did we just say it would do? Translate left. What do you think is going to happen if we subtracted?
Going right.
It's going to go right.
Sorry. I'm here.
Okay, so what characteristic will your h value tell you right away if we know that it's moving everything left or right?
It's going to be negative.
Think about the parent function. The parent function started with the asymptotes at 0, right? So if we know that our h is going to be 2, is our asymptote still going to be at 0?
No.
So what does the h value tell you right away?
Yeah,
Which asymptote? The vertical or the horizontal? Which one moves left and right? Vertical. So let's put that right here. If you know your h value, you know your vertical asymptote right away. Oh yeah, sorry. And we know it's our vertical asymptote because it's moving the x's, and x's are your vertical asymptotes. Okay, let's see what you remember. Which of these is going to be the one that shifts you up and down? Your A or your K value?
Your A. Or your K.
So is adding or subtracting is shifting up and down, or is multiplying shifting up and down?
Isn't it? Adding.
Adding and subtracting. If you think back to my scenarios, I would say I'm 6 feet tall. If you add or subtract, I'm going to go up and down. If you multiply my height, I'm going to stretch or compress. So that's something different. So the K value, the number outside right here, is adding or subtracting to the output. What is f of x the same as? Y, right? So if you're adding or subtracting to your output, do I need to solve for y?
No.
No, because y is already by itself. So are we going to do the opposite of what K says?
Yes. Yep. No.
No, the only time you do the opposite is if it's affecting the x, which is h. That's the only one that's opposite. Okay, so for K values, you're affecting the output. You're affecting your y's. So if I add or subtract something to my y value, how is the graph going to move?
Or up and down.
Up or down, because the y's move up or down. So let's go back to our calculator. I'm going to clear it. Remember, here's the parent. Right there, that's the parent function, just so we remember. It's at 0, 0, the asymptotes, yes? Okay, so now I'm going to go back, I'm going to clear this. If I'm trying to put a K value in here, would I put it inside the parentheses with my X? No, we're going to put it outside the parentheses because it's affecting the output, not your X. So I'm going to put +2 on the outside.
We don't have to put that in like a parenthesis like on its own.
No, because it's outwards, unless there's something with it too. Okay, so now what happens to the graph? Are the asymptotes still at 0, 0?
No.
The graph got shifted what? Up. Everything moved up too, including which asymptote? Which asymptote also moved?
-2.
The vertical or horizontal? The horizontal, because horizontal is your y value, yes? So then if we added a k, we know it's going to shift up. What's going to happen if I subtract k? It's going to shift down. And if we know our k value, which asymptote do we know right away? The horizontal. Your k value will tell you the horizontal. Okay, so really quick, we're going to flip it on the back side, and we're going to practice just identifying the h and k and what the asymptotes would be. And we'll come back to the a value. Because if we stretch or compress, making something taller or shorter, and you don't move the position, you're not going to move the asymptotes. So I just want to focus on this really quick on the back side. Let's look through some examples. Flip it over. Okay. I want you to tell me if it has an h value. So does number 1 have an h value? Remember, this is the parent function. Do you have an h value?
No.
Okay. Does number 2 have an h value?
Yeah.
What is it?
2.
2. So if I add an h value, what transformation is that? If you're changing your x, it's going to go left. So we're going to translate left how many?
2.
And what does this imply then? If you're going left 2, it's changing your x value. I told you that this represents what characteristic?
Vertical.
The vertical asymptote. So my VA is going to be at -2. Because you're going left 2. Does anybody have a question on that? Okay. Let's go to the next one. Does number 3 have an h value? Does number 4 have an h value? What is it? -2. So this one we are subtracting h. What does that mean it's going to do? Translate right how many?
2.
So if we're translating right to, what would be the vertical asymptote? +2. Isn't that a lot easier than having to factor and then setting it equal to 0 and everything? If you know the transformations and I'm giving it to you in this format, then it's a lot easier. You just have to remember the transformations. Okay, number 5. Careful. Do you have an h value in 5? Why is 3 not an h value? Because it's not adding or subtracting, it's attached. And that's being multiplied. That's something different. H value is being added or subtracted. Do we see the difference between that and having an h value here? Okay, what about number 6? Does it have an h value?
Yeah.
What is it?
3.
The plus 3. So we're going to be adding an h value, which means we translate which direction? How many?
3. So negative 3.
So then what's going to be my vertical asymptote if I shift everything left 3? Negative 3. Oops, I forgot VA. That says V. It looks weird. Okay, what about 7? Does 7 have an H? Yes, it does. We are subtracting the H, which means we're translating
Right.
how many?
1.
So if I translate right 1, where's your vertical asymptote going to move?
Right.
Which is at
Negative 1. Over 1.
1. The H is opposite. Okay, number 8. Do we have an H value? Yes, it's plus 4. So we're adding H, which means we translate
Left.
left. So what would be my VA?
Negative 4.
What about 9?
No.
All right. Do we understand how to identify an H value transformation and what the vertical asymptote would be? Okay, now let's do the K values. Going back to number 1. Does 1 have a K? Does 2 have a K? Does 3 have a K? Yes. Because we have a number on the outside affecting the output. What's the number outside?
Negative 8.
So we're subtracting K on this one, which means we're going to shift where? Down 2. And what does that move? If you're moving it down 2, which asymptote is this?
Horizontal.
Horizontal. So our HA would be y equals
Negative 2.
-2. Does 3 have a K? Oh, I just did that. My bad. 4 I meant 4. Yes, it does. It's what? Plus 3. So then we have a plus K on this one, which shifts it. So then that tells me my horizontal asymptote would be where?
3.
Y equals +3. Does number 5 have a K? Does number 6 have a K?
Yes.
Yes, what is it? So then over here we have minus K as well. Shifts down 1, which means my HA is,
Negative 1.
I should probably separate these. Y equals -1 because you moved it down 1. All right, what about 7?
Plus 4.
It's +4, so this one we would have a plus K, which means it shifted up 4, which means my HA is
4.
Y equals 4. Number 8,
No.
number 9.
Yes.
Yes, we have a plus K, which means we shift up
2.
2, so my HA is
2.
Y equals 2. Okay, any questions on how to determine an H or a K value?
No.
Then we got one more transformation, and we're done. And that's your A. Can I move it?
Wait.
What? You good? Okay, flip it. So your A value is a little different. Your A value is being multiplied to it. If you notice, the A is kind of by itself up here. I'm going to walk you through what it could look like. So here's the parent function, 1 over x. Let's say I wanted to stretch this. What does it mean to stretch a function? Make it taller, right? Like if I'm 6 feet tall, what could I be? to stretch? 6 feet's not stretching. That's the same height.
16.
Okay, stretch to 7 feet or stretch to 12 feet, which means you're getting taller. So give me, what would you do to me to make me taller? You're going to multiply me by a number bigger than what? 1. Because what's 1 times 6? Still 6. So what happens if I multiply 1 over x by some number bigger than 1? Give me a number bigger than 1. 10. Okay, and we know how to multiply fractions. You multiply how? How do we multiply? Straight across. So then this is the same thing as 10 over x. So do you see why the a value appears sometimes in the numerator? It is being multiplied by it. It is in front of it. It just attaches there. Okay, so what if I say I want to stretch by 3? What would it look like? 3 over x. That would be stretching by 3. What if I said I want to stretch by 7? What would it look like?
7 over x.
7 over x. Now I have another one. What if I compress? What does it mean to compress? Smaller how? Like shorter, vertically shorter, right? So if I want to compress, am I going to multiply by a number bigger than 1?
No.
You're going to multiply by a fraction. So these were all examples of stretching. You can write them if you want to, but these are all examples of stretching because it makes you taller. But if I want to compress, give me a number that would make me shorter. If I am 6 feet, multiply me by 1/4. What's a fourth of 6? That's not that easy. Let's pick another one. How about a half? What's a half of 6? 3. That makes me shorter, right? What if I want to take a half of this? Well, then I start with the 1 over x. I multiplied it by 1/2. Is 1/2 going to appear in the numerator? No. What is it going to look like? Nope. 1 over 2x. Do you see how the 1 over 2 right here is a fraction that's attached to the x? It is being multiplied to it. Do you see that? How it's being multiplied to x? So 1 over 2 is my a value, not just 1. That means we compress. What if I said compress me by a fifth? What would it look like? 1 over 5x. What if I said compress me by 2/3? 2 over 3x. What if I said compress me by 5/8?
5 over 8x.
Okay, now here's another one. What if I said compress me by 0.5?
0.5 over x.
You could write it one of two ways. It could be 1 over 2x because that's the same as 0.5. Or, say it again, Alex.
0.5 over x.
That's still less than 1. So do we understand what an a value would look like to compress? If it's a fraction, less than 1, it makes you shorter. If it's a number bigger than 1, it's going to make you taller. So let's go fill this in. A value. If a is greater than 1, what do you do? Stretch. Now if I get taller, does that mean I moved my position? So does this have any effect on the asymptotes?
No.
Nope, absolutely none. Okay, what if the a is in between 0 and 1, like decimals? What does that mean? Compress. All right, the last one with the a is, what if it's a negative? Everything becomes the opposite. It flips. What's the word for flips? Reciprocates. Okay, well, I get you, but on a graph, when you're flipping a graph. There you go, reflection. I was like, I understand why y'all say reciprocate because we're dealing with fractions, but well, we're talking about the graphs right now and their transformation. So if it's negative, it would be a reflection. So what would it be if I wrote this?
X over -2.
No. I'm asking what transformations would I have? Reflection because it's a negative a. That would be a reflection. And what would the 2 do? A is greater than 2 in a sense because think of the negative as being outside. When you ignore the sign, you think of just the A there. So if A is bigger than, oh, I put 2. A is bigger than 1 because it's 2. It would cause a stretch. All right, let's flip it over and finish the back side. The more examples you see, the easier they get. All right, number 1. Let's go with Frankie. Give me one transformation. Okay, it's stretched. Why? Correct. Okay, Gage, tell me another transformation for number 1. Well, look at the front. Figure it out. We already said stretch because A is bigger than 1. So it can't compress and stretch.
Do you see what the negative would be like on the outside?
Negative is like on the outside. So what does that negative do? Read. It says negative there for you. So the negative, consider it its own thing. That would be a reflection. When you think of the A value, think of it as just the number without the sign. Because it doesn't matter if you're positive or negative. That's still the same distance above and below. The negative just refers to, are you a positive on the top, or are you going to be flipped upside down and be on the bottom? That's all it means. Okay, is there an H or a K? No, because we already did those. All right, number 2. We already did the H value, but did it stretch or compress? Why nothing, Sully? It's 1. If I multiply 6 feet by 1, I'm still 6 feet. So you did not stretch or compress. The A value is just 1. Stayed the same. Moving on to 3. Do you have an A value? No, you do not. Moving on to 4. Do you have an A value? No, you do not. Moving on to 5. Do you have an A value?
Yes.
What is it?
Reflection.
It's a reflection because we see the negative outside, right? So we're going to have a reflection. Is that the only thing?
Yes.
Well, the reflection is just the negative. So you're saying 1 over 3x is the parent function?
Oh, it's talking about this side.
Wait, what?
We took care of the negative.
Fine.
The negative is reflection. Is 1 over 3x the parent?
Yeah.
No.
So then 1 over 3 has to mean something. What does that mean?
Compress.
That's a compression because 1/3 is in between 0 and 1. That's a compression. Okay, number 6. We took care of the H and K, but what's the A value? 1/4, because you see that 1/4 is attached. It's being multiplied in the front. So what does that mean if it's a fourth? It's also compression. Okay, number 7. What's your A value? 5. Not a fraction? It's not 5 over something? No, it's just 5, which means it's bigger than 1. So what did you do? Okay, number 8. What's your A value? It's 2/3 because the fraction 2/3 is attached. So if it's 2/3, that's less than 1 or bigger than 1? Then that means I what? Compress. Oh my gosh. Y'all didn't see that. I put an A and then a 0, and then I had to fix it. Okay, then the last one. Number 9, what's the A value? 1.5. So is that bigger or smaller than 1? Which means I'm stretching. Okay, questions on transformations. I know I kind of threw this at y'all, but we've done it before, so I didn't want to spend a whole 3 days on doing transformations. I figured you guys could have picked this up pretty quick.